Hi. So my lecture today is going to be on going out and looking at your competition to judge your work. It's one of the things I find students are very lacking in is actually going out and trying to actually see what their competition is, see how they can learn from their competition, see what they're doing, and how you can adapt to that. And so I find that a lot of students just aren't doing that. So I'm going to take you through how I think you ought to be approaching evaluating your own work. It seems like a lot of students are waiting for somebody else to evaluate their work, like they want me to evaluate their work, which I will, the other students to evaluate their work, which they should. But the bottom line is you need to be able to evaluate your own work, okay? I see too many students that look at their work and go, oh, my work's really good, when it's not. It's not that good. And I don't know, you have to look at yourself and decide why that is. There's all kinds of reasons. People sticking their head in the sand, just, hoping, that it's going to be good. Excuse me. Almost all of the students that I ever run into have this ability to do the things they need to do. They just kind of live in a little bubble, okay, and don't really go out and, compete. They don't want to compete, which is what you're going to be doing. I mean, these idea that you're going to go out and compete for a job and you don't want to go look what your competition and what they're going to be turning in and how you could do something like that, that's where the problem lies. So I'm going to take you out in a really good place where you got to start. ArtStation's a great place, but a really good place is Sketchfab, because Sketchfab, we can go in and look under the hood, so to speak. So we're going to do that. So I'm going to be showing some students' work. I'm not picking on any student. I'm just showing it as a basis to jump off. So this is not about the student. This is just a basis of where to jump off and then how to go about making your stuff better. So you have to decide whether you want to watch this video or not. I have some students, specifically students at some of the schools I teach at, that really don't want to know. They just want to act like they want to work in the game industry and stuff, but they don't really want, true hard criticism of their work. They just kind of want a pat on the back. They want a participation award. So if that's you, fine. There's nothing wrong with that. But then you probably don't want to watch this video, okay? Because the video, I'm going to be honest about the stuff that I see. So here we go. Okay, so this is a piece that one of the students has turned in. And first of all, this is a really bad presentation. It's just a sloppy presentation. It's kind of like somebody didn't really care, to do a quality presentation. They just do a quick screenshot and then throw that in there. I've got a video that I posted up on how to do quality presentations. The thing that you have to know is when you're in this industry, if you have really, really good work, but you do a horrible presentation, then it's bad work. Okay. But if you just do decent work, but you do a great job in your presentation, then it's great work. So it's all about your presentation. Okay, having said that, so here's a little farmhouse. Okay, so the students want to do this little farmhouse. Excuse me, it's a game model. Basic structure of this looks fine. It's the beginning. There's a lot of issues with this. The scale is really off. So in other words, if you were to blow this up, of course, this is as big an image that they gave me, and you would see that the thickness of where this window is about 2 foot, and we're doing a little house. The windows aren't 2 feet thick, so it's got some scale issues, and a lot of this just because people don't take the time to get quality reference to go from. You may be going from a sketch that somebody did, which is fine, but that's just the beginning. The first step is the sketch, and the next step is research, where you go out and you find all kinds of research of what it should look like to help you with that sketch. Okay, so here's the kind of thing the person has built, and this is definitely can be taken into a portfolio. It's just got to be finished out. So we're going to go in and look at some over on Sketchfab. Okay, so let's just take this away. And so here's Sketchfab. Okay, and what I've done is just did a search for old huts. And then you come through here and there's all different kinds of old huts. You know, you got things that are more believable, things that are more cartoony. Okay. So that's just according to the direction you want to go. And so there'll be all kinds of things in here. Now I'm going to take a couple of these and we're going to look at them. Because there's a lot of, you know, not good stuff over here on Sketchfab too. And we can learn a lot from that. So let's go in here and look a couple of these. Okay, let's look at this one. Here's one that I found, and this is a pretty good one. So just so you know how Sketchfab works is, you know, it's an interactive viewer, and this is what I recommend that you guys do. We're going to be putting our stuff up on Behance, and you can embed these viewers in there, and this is really advantage for somebody when you're showing your work, that they can come in and kind of see under the hood, so to speak. They can see all your textures and everything if you set it up correctly. So this is a pretty nice piece. Okay, so I'm just using my left mouse button, can tumble around. You can also hold the Alt down in your left mouse button, and you can move the lighting around to see how lighting is going to skate across the surface. So we can move the light around to see this side, or I can come around the back. So I'm Alt, left mouse button, you know, to move the lighting around. All right, now, center mouse button moves. And now if you'll look down in the bottom right-hand corner, there's some icons in here. And there's a little stack icon with 3 little pieces of paper stacked. This is called a model inspector. This is going to allow us to go in here and inspect the different parts of this model. So when I click on that, you've got a set of menus in here. Now right off the bat, I'm going to encourage you guys to work with PBR, physical base rendering. And what that means is when you look in here, I should see a roughness map and a normal map. Okay, if I see a roughness map and a normal map, then this is PBR. If I don't see a roughness map and a normal map, then it's not PBR. Okay, I would only look at ones that are PBR. Okay, the first thing I do, so when I have a student that's doing some of this work for me and they turn it into me, the first thing I do is I come over here and I click on matte cap, and this just shows me a gray shader on this. And then when I click matte cap with surface, this is going to show the normal map put on it. And you'll see this gets so much more detail when I go from the matte cap. This is with a normal map. And then with the normal map, it's putting all this extra detail in here. That's what the normal map's doing. Now, I'll also go down here and look at the wireframe. This gives me just a white with a black wireframe on it. And this tells me all kinds of things too. This is a pretty clean model. It does have a few issues, but overall it's a pretty clean model. For example, this right here, you see this where this is cut into this. There's no reason for this to cut in two, but it doubles the amount of polygons that are in this piece. So this piece, and this piece, to me, now it's one thing if the wood was like broken or something, but this is straight across. There's no reason that this is cut in half but it doubles the amount of geometry on each one of these boards. So I would fix that. Same over here. But overall, this is a pretty nice model. Okay, no problem with this. Okay, we can also do a UV checker. Okay, this puts a checker pattern on it, and I'm going to show you how to look at this. Now, what you're wanting to see is that these are squares and they're not stretched. So if they're stretched in any way, then that's an issue. But then the other thing we want to look at is pixel density. That's the density of what the pixels are going to show up. So as in right here, can you see how this number is smaller than that number? That means we're going to see more detail here than we are there. So the pixel density which you can think of as pixel density. It's only pixel density once you convert it into a bitmap. So in three-dimensional space, it's referred to as a texel density. You can see the bigger these areas, like the numbers, you can just look at the numbers, the easiest thing for me to look at. And the bigger the number, the less detail. So this wall is going to have less, it has fewer amount of pixels in its bitmap than this does. Same thing in here. This is going to have more pixels on it than this in here. So you'll see a shift in the sharpness, in which that the smaller the structure is, the sharper the detail will be, and the bigger, the more blurry the detail will be. So that's kind of how you can see these on this window right here is really highly detailed. Now, the thing to me that's a little funny about that is this window is going to be translucent. We're going to be looking through it, which is why it's translucent right now, which means we see less of what's on it. So to me, it's kind of odd that this is more detailed of what we won't see, which is kind of odd to me. So I wouldn't do it that way. Okay, so that's kind of what this helps us kind of evaluate, is how to make sure there's no stretching and to make sure that there's consistency in texel density. Now, there are times where we can vary our texel density. For example, on a character, we might want more texel density on the face of a character than we would, say, on the bottom of the foot of the character. But most places, one of the things they're going to be checking you is your ability for you to be consistent with your texel density. Okay. Now, another thing that we can do, I'm going to go back to my wireframe, is right up here, this says 3D in your viewport, and then it says 3D, 2D in your viewport. And what this does is it splits your viewport where I can see the unwrap of the bitmap over here for this piece. Okay, so I'm seeing it's 3D and 2D, and this can be zoomed in and moved over. Okay, and I can look at just the 2D if I want to. But this is a good valuation. Now, do you notice how when I put my mouse over here, this is changing from yellow and then just yellow here and then it's yellow here? That's because when the person did this, they're using 3 different bitmaps. They didn't unwrap it all on one bitmap. Every one of these yellows is a different one. So when I click on this, you'll see that my bitmap over here changes because this is the bitmap that's used for this. If I click here, it's going to show that bitmap. If I click up here, it's going to show that bitmap. So really, let's see, and right up here in the top right-hand corner, yeah. So they've got 4 different bitmaps in here. 4 different bitmaps. They've also got an interior one. So this is a model where they've done the interior too. So we can actually go in and look at that. So they've got a bitmap for that. Here's the bitmap for the glass. So they got the glass on its own bitmap. I don't see a reason that you would do that. Maybe it's a really small bitmap, but anyway, so this has 1, 2, 3, 4, 5, 6 bitmaps for this, which is, seems to me would be a little bit of waste. I could have probably done it and it'd look about the same with maybe 2 maps, 1 map, 2 maps. Okay, so that's what's going on there. All right, so let's go back to 3D. Now let's look at some of these maps. All right, so I'm going to go to the specular. Okay, now the specular should be a mid-tone, which is what it is. Okay, what this is controls the highlight that's going to be on anything that's not metallic. And so it should just be left at its default setting, which is about 50%. So that's correct. Now, I've got an emissive here, and I don't know why they've got an emissive because I don't see anything that needs an emissive. So I'm not sure why they're causing us to process an emissive map. Emissive map is glow, like a candle light, and they don't have that. Now here's their opacity, okay, and this is why I was saying we can see through the window. So in an opacity map, everything is reading from white and black. Okay, think of it this way. White is on, black is off, and gray is a transition between them, okay? So where this is becoming darker, where it's white, it's opaque, Okay, so white's 100% opaque. Black would be 100% transparent, and then gray is translucent. Okay, so we see part of the way through it. Look how they've got a nice roughness to this. Okay, this means that this glass is going to come off as kind of dirty, wherever it's darker, we can see more through it, and where it's a lighter gray, we see less through it. And so that's nice that on the surface, they didn't just make it a solid gray, they're making it varied so that the amount that I can see through it varies. Okay, that's on an opacity map. Not everybody will have opacity maps because you may not have something that's translucent. Okay, but in this case with the windows, that's kind of nice because we can see it because this person textured it inside too. All right, we go to an AO map. Now, AO stands for ambient occlusion, and what that means is anytime you have two surfaces that go together, okay, the light's going to make it dark where they go together. Okay, that's an occlusion. Okay, so what this does is this is a lighting that shows how because light emanates in an orb, so it's round. So anytime you get two things that are creased together, it's going to get darker in there. Now, personally, I think this is a little heavy. It's almost what I would call a dirt map. I think it's, it goes up too far. I would have controlled this so it was a little bit tighter, but this is creating the shadowing that's inside. Of course, you can see inside of this window, and we can see inside of there. And that's an ambient occlusion map. Okay, here's your normal map. And a normal map is a type of a bump map. So a normal bump map is black and white, whereas white pushes out or up. And gray is no movement, and black is back or in. But we're at a state now where we use this advanced bump map. It's called a normal map. And so this is the normal map. Now, this is what's being applied onto this matte cap. So when I go to matte cap and I'm just seeing the geometry, as a matter of fact, I can go up here if I want to, and I can turn the wireframe on it. Okay, and then once we get matte cap surface, then we're applying this map. And this is what it looks like, and it's giving us the illusion of three-dimensional depth. Okay. As a matter of fact, we can see here. Let me turn the wireframe off. Can you see, and I don't know how much you've been seeing this video, that this right here is much sharper detailed than this in here? This gets really fuzzy in here. Okay. That gets back to your UVs. See how small this number is, 14, and how big this is? That means there's more detail here, less detail there. And that's what we're seeing here, is we can see all this nice detail of this wood, which is nice, and then it's very fuzzy in here. And that's because their textile density varies. And I can tell you really why they're struggling with that is because they're doing multiple bitmaps. And so it's harder when you have multiple maps to make sure the scaling is the same. But that's what's causing that. Okay, so that's your normal map. Okay, then you have a roughness map. Okay, the roughness map is one of the heroes. Okay, one of the hero maps. Everybody should have a roughness map. Roughness map determines how glossy or rough the surface is. So white is off and black is on, and since it's in a roughness slot, that means white is rough or dull or matte. Okay, black, if it was black, though we don't have any black in here, a little bit maybe right in darker right in on this handle, is reflective. Okay, pure black would be like a mirror. So gray is a mid-tone reflection. So where this is lighter, it's going to be very matte and dull, and where it's darker, it's going to be shinier, and then the other gray is fall off in between. So this varies the surface so that it's not the same sheen across the surface, that some areas are a little bit more than the others, which is what happens especially over time when things age, because basically on a house like this, you have a piece of wood, then it's usually painted with a primer, which kind of seals the wood, and then they paint, an enamel on the outside of it. Okay. Over time, weather with rain pounding on it, and also UV rays from the light fading the paint, then the surface varies, where some of it is a little bit more shiny and some are less shiny. And so that's what's controlling this. Okay, then you have a metalness, okay, shader. So basically your material has two algorithms in it, okay? One of them is an algorithm for normal non-metallic surfaces, okay? They're broken down into what's called an insulator and a conductor. This is from science class. A conductor is anything that conducts electricity, which is metals. And an insulator is anything that doesn't conduct electricity, okay? So in a metalness, anything that's black is a non-metal shader in it. Anything that's white is a metal shader, okay? Normally, these would only be black and white because something is either metal or it's not metal, okay? And I see people all the time putting a lot of grays and stuff in it. And I'm not saying you can't do that because you may have a specific look that's a non-believable look. But if we're based on physics, something is either metal or it's not metal. Now, the exception, and we can get in here on this little hinge in here, and you'll see there's some grays in here. And what happens here is metal, through weathering, will start to oxidize. So we have oxygen in our atmosphere is a corrosive. And we have oxygen in water. So basically we can think of water as like an acid, okay? And the oxygen in the atmosphere is like an acid, and it attacks metal. So what's happening here is you're getting oxidation built up on this metal, okay? Well, oxidation is like you can almost think of it as like a fungus growing on it. And so that oxidation is blocking the metal. So it's a metal surface, but you've got this organism, kind of the way you think of it, growing on it. And it's kind of obliterating the metal. So it's like a coating on top of the metal. So in those particular cases, we can get in with some gray in there where we're still seeing a little bit of the metallic attributes through that, but it's starting to grow something on top of it. Other than that, it will normally always just be black or white. So since it's in a metalness slot, white is off and black is on, okay? And so we put metalness in here. If you don't have metal on yours, then you won't have a metalness, okay? All right, so white is on, black is off. So anywhere that's white, metal. Anything that's not white, black, is non-metal. Now, they're indicating here that this has some kind of a metallic surface. So this is like a tin roof is what I'm getting from this. So it's not a wooden roof, it's like a tin roof because it's metal. Okay, base color. This is where we're just doing flat color. No shadow or anything. It's just flat colors. I say flat color, or it could have pattern in it too, but I mean it's no shading. Now, we can inspect here too. So when we're looking at a base color, if we go over here, let's go and click this surface, then you'll see here is that color. Now they put this pattern over it so people can't, steal people's texture maps. I hate it because I'd like to be able to evaluate somebody's texture map more, but it's something that they added at one time in here. Okay, so that's your base color. Okay, then you'll see in here it's got final render and a no post-processing render. So we click here, and this is stacking all of these maps on top, and this is what it looks like. Okay, and we can move the light around to see it. See, we're seeing that sheen up there on that metal tin roof. And then you'll have one that says final render, and you'll see there's a shift in here, okay? And so the inside of Sketchfab, there's some post-processing that we can do. Like it's got a vignette, darkness in the corner. That's what happens when we shoot with a camera. The light is an orb, so it gets darker in the corner. So there's kind of effects we can do. We can throw a shadow underneath it on the ground plane below it. So that's kind of your procedures of how you can go in here and you can see people's stuff. So let's look at another one here. Here's another one that I found in here. Okay, initially that looks pretty good. This looks a little odd because this wood grain is not going the right way. This wood grain's not going the way. A lot of people struggle with wood. You know, that you could tell this wood grain's not going correctly. So, you know, their wood's got a lot of issues. I'm going to open up the stack. Now, you're going to see over here that there's not as many controls as the other one had. Okay, so this is an issue. This is not, to me, this is not something that's would really impress somebody out in the industry, because there's so much that's missing from it. Okay, first of all, it doesn't have a normal map, so there's no dimensionality to it. Okay. The other thing is weird. They've got their specular set at black, which means even on our roughness, which they really don't have in here, it's not going to show a sheen on it. So that, you know, there's nothing in the roughness. I don't know why they have it on. Let's look at the metal. They have nothing in their metalist map. So basically, this map is nothing other than a base color. That's it. It's got a base color on it, and that's all that's in here. So to me, this doesn't. What you're looking for is opportunities to show off your skills, and one of the skills is showing your ability to control the surfacing, and the most robust surfacing and the most that's used in the industry is PBR. So even though this looks pretty good, you know, and it's not that you couldn't show somebody this, but it's got issues with the wood, and then you're not taking opportunities of your shading attributes in here, your material attributes. All right, let's look at another one. Okay. So another little hut with a little grass on the top. Let's look at this one. Okay, so here's our map. Let's go ahead and look at the wireframe. Okay, so I don't know what software this made. If you're modeling in Maya or Max and you export as an FBX, and you don't mess with the settings, when it comes in, everything will show up as quads. Now, in the end, this is not a big thing, because once it goes into the game engine, everything's triangles anyway. But it's just not as clean a presentation. You know, and I would have done some turning here. See how these angles are going like this? Okay. Light on an object is hitting the vertices. So we think of the light as hitting the surface, but the reality is when it's calculated inside the render, it's hitting the vertices and it's averaging across the surface. Well, so this is going to have a hot spot right here, because all of these triangles come down to this. I could have come in and turned this triangle so it went the opposite way, so that we're distributing the lighting information more evenly across this surface instead of having this hot spot right here. Other than that, this is okay. All right. So let's look at some other things. So here's our just gray shader on it, and then let's click matte cap surface and see how the texture changes. Okay, there we go. See how that texture is popping out on there? That's your normal map. So that's all the detail that's coming in from the normal map. So from there to there. Okay, let's look at our specular. Okay, this is really funky. So this is a person that, in my mind, doesn't understand the process, because when you're doing roughness, we don't use a specular. Oh, okay, so they've got it backwards. They've got this backwards. So this is the roughness map, which should be in the roughness slot. They've got these two backwards. That's interesting. So this is the roughness map, which should be in the roughness slot. And then the specular should be white, not the roughness white. Let's look at an AO. Okay, they've got an AO on there. It's kind of broad, making it kind of a dirt map. Metalness. Okay, what's going on with this? Oh, okay. So this is definitely something that whoever's showing somebody this, the people that would be looking at this going, okay, they have no idea what they're doing. Not that they don't have no idea, because, they've done some good things here, but a metalness map is trying to indicate what is made of metal and what's not made of metal. Okay, well, these bricks are not made of metal. These stones are not made of metal. And definitely the grass at the top is not made of metal. Okay, so none of this should be in a metal. This shouldn't have a metalist map because there's nothing that's metal. You could have some things like some metal nails or something in it. Maybe a bucket down here that would be metal, but nothing in this. This shouldn't be right. Here's your base color. By the way, this grass on this grass hut is way out of scale, and that's an issue. A lot of times people have a problem dealing with the scale. It's way out of scale. It's making this look really small because of the scale of this. Okay, so there's the render, then the final render, and it looks like, yeah, they're running a sharpness filter on it. Can you see this is kind of fuzzy? What happens when I click this final render? It becomes a little bit sharper. They're running a sharpness on this. Notice how they got seams in their texture. Can you see that seam there? There's a seam. There's a seam. I don't know of you can use a seamless texture on this, and there's nothing wrong with that, but it's got to be a true seamless texture. With this one's not, or it's got some issues with it. Okay, I like the piece, but to me it's got some issues, and I would rework it. Okay, so that's looking at some of your competition and trying to learn from what they're doing or what they shouldn't be doing, what you should be doing when you're finishing up a prop, an asset that you're going to put into a game engine. Okay, I hope that helped some of you guys. Reach out and ask me some questions if you want any clarification on any of this. I just do this as to kind of help you guys because you get great opportunities to, flush your models and assets out if you take the time to do it. And then, this is the way you should be showing your work too in the end. Like we're going to be putting our stuff up on Behance, and you can embed this stuff. Okay, so if I go right down here where it says embed, I can click this. And I would tell you to come in here and turn this fixed size on so it's larger, and then you copy the code here, and then that can be put up in Brightspace. So like if you've got your stuff up on Sketchfab and you want to show, you can embed that in Brightspace, and this code can be put inside a Behance also to show your work inside of that, which is where we're going to end up moving with our final portfolio. Okay. Hope that guys helped you. Thank you.